Hi, I wanted to give an update on my grass, dirt, path related stuff. So the problem is, how do you store data for paths, dynamic paths that can be created as you walk? Before I was using Vertex color, but this required me to subdivide the surface. So now I'm using images. There's actually two images involved in this. This image defines bounding boxes, or it stores data for bounding boxes. The bounding boxes encompass the area where grass exists. The image over here is storing data about where the dirt is and how intense is the dirt. This is a very wide image. These little streaks you see on the wall should actually be, these are actually 1 pixel tall, it's just stretched vertically. But it's storing a bunch of data in images. And you might think that UV2 or light map UV would be a really good way to tackle this problem, and I mostly agree, except that in Godot, when you try to raycast to a mesh surface, you're actually colliding with a collider mesh that is separate from the display mesh and doesn't have the data for UV position and things like that. So in order to use UV2 for this problem, you would need to be able to convert a 3D position into a UV2 position, which I'm sure there's some way to do it, but I went with a different approach because I already had it started, and yeah, I don't know. This approach is pretty cool the way it works. So these are 3 bounding boxes that I've created. You can imagine these bounding boxes as being broken into like a grid where every cubic half meter there's like a grid square, and there's an 8-bit value there defining how much is it grass and how much is it dirt on a scale of 0 to 255, or 0 to 1 with 8 bits of precision. So these bounding boxes, I can move them, I can resize them, and they display in the editor. And then for the main script though, I create an array of these bounding boxes, sort it by volume because I think that would require less checks on average if you're more often in the largest box. And then I find the total number of cubic meters, I loop through the bounding boxes, and I am not only storing the position and size of the bounding box, but also a data offset. It starts at 0, but every time it loops, the offset increases, and this is useful for the shader later. And I'm actually storing all this information in the red and green channels of an image. I showed that image in game, but now I will explain it. It's going across horizontally. This is the position X, position Y, position Z, and then this is size X, size Y, size Z, and then this is 4 bytes or 2 pixels with 2 color channels for the offset. And as you can see, the first bounding box on the top layer is pure black for the offset because it's 0, and then it increases as it goes down. So this image is 3 pixels tall, and it is 1 for each bounding box. So that gets sent into the shader as an image. And when I create this, I actually I need these precise integers, and so I mean these would kind of be like 16-bit signed integers, but because of these different data formats, I'm just trying to simplify it. So I add 32,768, so there's no negative numbers, and then I subtract that off later. 16 bits gives me that range of 65,536, which is large enough to use in any size level, basically. And yeah, storing the offset as 4 bytes. And then, yeah, send that to the shader, and then I need to calculate the height of the path collision data image. And this is the total number of cubic meters times the blocks per cubic meter, and then divided by the image width, which I've arbitrarily defined to be 8,192. It's just a multiple of 2. And then I divide that by 4 because I can store one piece of data in each of the 4 color channels per pixel, and I round up. And I create the image. This is in format RGBA 8. It does do sRGB conversion, but I can convert it back in the shader. And maybe there's like a tiny bit of imprecision in doing this, but yeah, unfortunately this forces an sRGB conversion, and I was trying a different image format and there was like problems getting it to work, but I can like kind of undo this conversion in the shader. Whereas with this other image, I am only storing the 2 color channels on purpose to avoid the sRGB conversion. This is just something with the way that Godot does these image formats. Some of them have the sRGB conversion and some of them do not, so I don't know. I just had to kind of work around that. Yeah, so I create this image. It's empty. It's just filled with zeros, basically. And it gets created and sent to the shader. Now, I don't have to create it with zeros. I could create this from data and then use this data right here. And this would be a random number, random noise. I think this should be a 6 actually, but yeah. And if I run this with the random data, you'll see that it actually has quite an effect. It's basically saying that for every cubic half meter, it's randomly somewhere between grass and dirt, and you can see this image became filled with this noise. This is storing all of the data. So I'm going to undo that. Alright, so the next part of it is when the player steps. This function fires. It fires 10 times a second if you're running on the grass. We have the player's position and then the velocity length of the player, which is kind of useful for determining how intense to decay the grass or whatever. But I sort of want to do, it's sort of an equivalent of anti-aliasing, except with these 3D data blocks. So I want to find the 8 nearest blocks. I can do that by rounding the position to snap it to one of the blocks, the nearest one. And then if I take the original position and the rounded one, and I find the, is it positive or negative? That allows me to find the nearest 8 blocks. And now sometimes these signs will actually be 0 because, for example, if you're walking on a surface and the surface vertical height in the world is exactly like 1 or 0 or a whole number, then the rounded position on an axis is going to be equivalent to the position pretty often. So I only add it to this other positions array if it wasn't already there. So that allows me to like cut this in half and For example, if x sign was 0, I could get rid of all these and only have to update less blocks. So now I create this array of pixel positions to be updated in the data image, and I loop over these 3D positions, and I find the relevant bounding box, which is just like a bounding box has point check. Does it have the point? If it does, then it's the relevant box. And if no relevant box was found, it doesn't have to do that one. So what I need to do now is, with my 3D positions, I need to find where in the data image are we supposed to be writing to. So we're passing in a 3D position, and these are the rounded positions that are grid snapped, right? And we're also passing in the index of the relevant bounding box. So we have the bounding box, and then this sort of puts this in bounding box space by taking the position and subtracting it from the bounding box position. Like if you were in the corner of the bounding box, this should be 0. So this is like bounding box space. And then with the width and the length, or width and height, I guess, of the bounding box, I can convert this 3D position into a one-dimensional integer that represents which block it is in the bounding box. And then if I append the offset based on which bounding box it is, I should get the exact byte that must be updated. So now we have the index. Then I can do a calculation based on distance and velocity to determine how much I want to write to that value. So now that we have the index and the value we want to write, I can get the data from the image. The index divided by 4 is the pixel index. The index modulus 4 is the channel, red, green, blue, alpha. The image data, inside the data of the image, it is just an array of bytes, so I don't have to worry about like the width and height yet. I can just set the data and make sure it doesn't exceed 255. And then I actually do grab the pixel by dividing by the width and modulo the width and return that. And then I'm doing this texture set data partial, which updates like a single pixel for every pixel that I need to update. And that's basically all the code on the CPU. But there's also the actual grass itself. Alright, so it's a shader. It's got some uniforms. This is data that I can send into the shader. This is the block size, which is going to be 0.5. This is the bounding box data, which is that 8x3 image that I showed before. Collision data, this is the large image with all the grass dirt data. And then just 2 textures that I defined. Alright, so it starts with the vertex shader here. And for each vertex, I actually find the relevant bounding box that I need. And earlier, because I didn't want to deal with negative integers coming in through here, I added 32,768 to x, y, and z. So here I have it set up. So this is like the value offset that I subtract off. I subtract it here. But basically I use these shader texel fetches to get individual pixel data. And there's a trick here to, like, it's interpreting it as a float, but if you multiply the value by 255, add half, and then cast it as a integer vect4, then you're actually going to get back positive integers. I had help with this. I want to thank the Godot Discord for helping me with this. In particular, what was their name? Let me see if I can see it. I think their name was Liuma, but let me just double check that. Yeah, Liuma helped me with this. Thank God for that. So that was really helpful to be able to get these integers. Because from here I can actually cast it back to a vec3 and then combine the color channels. Like I'm adding the green channel to red times 256 to get a 16-bit integer. Same thing with the size. And then from here I can do bounding box checks. This is like, is point in bounding box? And if it is, then I found the relevant bounding box and we're done. And then I also need the data offset. So once again, I can get this integer by doing this 255 times texel fetch and then adding half. And I'm actually not converting this to int here because the varyings, the stuff you can pass from the Vertex shader to the Fragment shader, they have to be floats. So for now I just store the 4 values in a vec4 to get passed into the Fragment shader. So the Fragment shader runs once for every pixel on the GPU. Here I cast this to a integer vec4, and then from the integer vec4 I convert it to a single integer. All 4 bytes get converted to an integer, and then I have the data offset, because the data offset can be large. It could be like 500,000 or whatever. So it needs to be, I needed to store it with 4 bytes just to be sure. Alright, so now what I'm really trying to do here is find this value, texture blend. 0 is grass, 1 is dirt, anything in between is blended. So the vertex from the Vertex shader multiplied by the camera matrix gives me the world position of the vertex. Oh, it says vertex, but it's really like the pixel's world, like the pixel to be drawn, its world position. So I run this function, calculate texture blend. I pass in the position, the bounding box position, the bounding box size, and the data offset. So I'm able to get my data from that bounding box image, convert it to sane numbers, and then run this run this function. Alright, so here's calc texture blend. So there's something really similar going on here. I need to find the 8 most relevant boxes because I want to blend between their values. So once again, I'm doing this trick where I find the sign and get the 8 positions, and then based on how close that pixel is to each of the 8 positions, I assign a weight to all 8 positions. I normalize the weights so that it all adds up to 1. And then this actually gets the value from the data image, get collision data. So here's get collision data. I have the position again, the box position, the box size, and the data offset. And this is actually just like the function on the CPU to get the index. It's just like it. It does the exact same thing to calculate the index. And once again, the pixel index is index divided by 4, the channel is index mod 4, and then yeah, so here I'm just like, I guess I don't need this, or whatever, it's fine. Anyway, yeah, so if it's the red channel, I get red, green, blue, alpha. I didn't know how to like convert this channel int into like the channel here, so I don't know. But one thing special though is with that image, the red, green, and blue channels need to be converted from sRGB, so I have to actually run another function here, whereas the alpha channel can just return the value it grabs from the image. And the sRGB to linear just does some, I don't know, I just copied this function. So once we finally have the texture blend value, which is the combination of all the values and all the weights to get like the smooth blended value for what the dirt value should be, it returns it. And then it just does like a linear interpolation between the grass texture and the dirt texture at that particular UV coordinate, and that's what it draws to the screen. So that's it. Took me some days to get it working, and I think it's kind of cool. Yeah, I think perhaps using UV2 would be nice if Raycast and Godot could give me the UV information, but no luck there so far. I think this method works pretty well. It's running smooth 60 frames per second. I think it's kind of cool the stuff it generates, like this image, and it all works. So that's pretty much what I've done. I guess I would like to start maybe saving this data between sessions so the paths like persist. And then another thing I might want to do is start thinking about how to actually generate blades of grass and other things on top, and then have those interact with the data from the image. Or, yeah. Anyway, thanks for watching.